Hello everyone and welcome to Handmade Hero Show. We code a complete game live on stream. We almost didn't make it today. We moved. We did an office move. And Can't Stop Moving, who was the moving company. I would not recommend this moving company. They destroyed the Handmade Hero desk. It's one of those like desks that has a adjustable height on it. And they I probably tried to ram it through a door without realizing that it has a control on it, and it just shattered. Like the control board was fractured out of the rubber housing, and one of the capacitors, or I guess my circuit board knowledge is not very good, but the actual there was a coiled wire and what looked like a capacitor cap or something was just split in half, and all the wire had come out. So it was pretty bad. So I was super depressed, and I'm like, oh man, what am I gonna do? Because that desk, it's pretty old. All the desks at My Rocket were from the old days, and they took a long time to get, and they're pretty expensive. And so I was like, oh, this is terrible. But then, John Blow recently, he had spent some time in Seattle, and he had actually gotten a desk, one of these desks. It was a Jarvis desk. It was from a company called Fully, and it was a pretty cool desk, and it had height adjustment. I was like, oh, where'd you get this desk? And did it take a long time to get it? Because I'm still thinking in the old days. And he's like, nah, you just order it online and it shows up. And I'm like, oh, that's awesome. So I'd had that in my head, and I idly mentioned this. I'm like, well, I don't know, this desk is probably toast, and there's no way I'm going to be able to repair the circuit board. I don't know anything about hardware. So I'm just like, I'm probably screwed. We're not going to be able to stream Handmade Hero for weeks. But Anna's like, well, let me just try it. Let me see if I can get one from that company. And she actually went online and she ordered this desk, and it showed up in 2 days. So clearly the process has gotten a lot better. People must use these kind of desks a lot more now than they used to. So basically this stream is definitely happening. Thanks to Anna and to John as well for having proved that you can get these desks nowadays in a reasonable amount of time. Hold on one second. I gotta get my tissues too. I don't know where they went. All right. So yes. So basically, the evil moving company tried to thwart the stream, but they were not able to, thanks to the heroics of John and Anna indirectly. And so now we are able to resume programming as we would have, which is very good. All right, so in theory, everything is working now. I checked on the Blackmagic capture card. It took us a little while during the pre-stream to get it set up properly back again. You kind of got to do a little dance. But it looks like it's capturing at 1080p 60 again, which means everything should be working okay. And I should be able to just start as if nothing had happened. And maybe, possibly, who knows, could be, we'll find out in a second, everything will just be fine. So we'll see. I'll try to keep an eye on the streaming too. This is the first time using the internet here. So we don't really know how that's going to go. But so far I don't see any dropped frames, so hopefully everything, hopefully everything will be okay. Let's get started. So, if you remember where we were, we had kind of done some exploration of the camera, and I couldn't really find a good way to get the camera really working in a way that I wanted to with a specified control curve, where we actually just specified a cubic for it. So what we ended up doing was just falling back to what I said we would fall back to if we couldn't, which is a proportional derivative controller. And those are pretty good, but there's some problems with proportional derivative controllers, which is that they sometimes will do some stuff that you don't necessarily want, and you have to potentially tune the parameters to be set appropriately to avoid things like overshoot or frame rate dependent stuff like that. But if you look at how it's behaving now, you can kind of see the camera's pretty nice, even so, with the proportional derivative controller, right? Let me go ahead and bring that up to full screen. You can see that it's doing roughly what we want it to do, which is that, it smoothly transitions between different camera modes and doesn't produce a lot of unwanted artifacts. So for example, when I'm hopping around in this scene, you can see that the camera is allowed to roam freely across the vertical extent of this particular room. And you can also kind of see that it doesn't do that horizontally. And that's by design, right? We specified that explicitly. We have different kinds of rooms there that do that. And you can also see here a sort of ease of transition. Like when we come in here, it's not tracking any motion of the player. It's just a static, right? It's not doing anything to track where the player is. It just focused on the scene directly. And so that it transitions between those modes nice and seamlessly, and that all feels pretty good. And if I go into, again, this is another vertical tracking room. If I go into a room that tracks both directions, so I believe this garden area outside here, that's a double track room. So I think it tracks horizontal and vertical. Maybe not. It looks like it doesn't track horizontal. I don't know if we have any rooms that are big enough for that. We probably should have some. We'll have to set those up later. But anyway, it seems to be tracking pretty well through there. And that all seems to be pretty good. So really what we have now is we can just choose to say, look, that's good enough for our purposes. Let's go ahead and double down on the proportional derivative controller and just look at some of the other things that we need the camera to do and maybe clean them up. So for example, if you look at this, you probably can't quite feel it on the on the stream necessarily, depending on how you're watching this, because again, the stream, isn't a perfect replication of what the player's actually going to see. It goes through an MPEG encoder and decoder, and there's some loss there, and who knows, the frame rate's not 60. I think I stream at like 30, so you guys don't quite see the full 60 frame a second feed, and you don't really need to, right? This isn't an action gaming stream. It's a development stream. So that's fine, but the point is simply that if you look at what's going on native, so what I can see on a 60 frames a second display, and I think we are running at 60 frames a second here. Let me see, where's our profile counter stuff here. So yeah, we are running at 60 frames a second, locked more or less right now. And so when you look at it at 60 frames a second, what you can see is that when the character hops along, it's actually following the character up and down with a certain amount of that hop. And so it's constantly trying to get the exact player location for the axes we tell it to. So if we tell it to do just Y or just X, it's not going to look at the other axis. It's not going to try to track that axis, but it is going to track the one that we told it to, and it's going to track the entirety of the entity motion. So if there's some entity motion that involves like hopping, you're going to get that wobble in the camera. Now, you don't see as much wobble in the camera as you do in the character. Like the character's doing a hop, and the camera's only doing a little bit of a damped motion. That's because the proportional derivative controller, again, it's proportional to how far off of correct it is at any given time. And so that's why you're not seeing as bad of a wobble, but it is there. And so one of the things that we want to do, I think, here is make it so that we don't generally, we don't consider small displacements of the player to be essential for the camera to track. We only consider like large displacements of the player. Do you know what I mean? So I think generally what I would say is there needs to kind of be some sort of an understanding there about what is and isn't supposed to be tracked by the camera system. Other than that, I think the only thing we really need to do with the camera system is bulletproof it a little bit against large frame time deltas. So we want to probably cap the speeds at which the camera might consider changes. And the other thing I think we want to do is we would like to make it so that we have a debug camera again, because we don't currently have a debug camera. Right now, we actually don't have any way to look at anything other than the actual game camera. If I switch, remember we still have the right mouse button will switch. We have nothing now. We have no debug camera support since we modified the camera. So those are some things that we want to get done. I think we could try to shoot for all of them today because they're not that complicated. really, but some of them are a little tweaky and weird. So I think that's what we should focus on today. And then I think after that we can maybe move on to something non-camera related. You'll notice too, we get some interesting things here. We've got an invalid code path here that looks like, again, we're having some kind of a entity count overflow. And one of the things that's interesting about that is the entity count appears to be set to 4096, even though I upped it to 8192 because we know we've got more entities now. That max entity count, you know, in the future, we might be able to say more specifically that we don't want a max entity count at all. We could actually say, look, we'll just handle as many entities as can fit in memory or whatever. There are going to be hard bounds on it because obviously there's issues with respect to how that's going to work. Is it just me, or is this text a lot smaller than it normally is? Would you guys say? I feel like this text is really pretty tiny. Do you think that's because we didn't reboot as far as scaling is concerned or something like that? Do you want to do a quick reboot? Let's do a quick reboot. Let me see here. Restart. Let me restart and get the all right. I just want to make sure that we're not, and we can also, oops. Let's see here. Yeah, see I think the scaling was wrong because we hadn't rebooted. That's what I think we know. Normally I would have a higher res monitor and a smaller font, so I could have probably used that, but I think this is what it normally is on stream, just to make sure that everyone can see it okay. So is that, I think for those of you who are used to watching the series, does that look more like what it should look like? Because I feel like what was happening there was it was getting an incorrect scaling factor applied. I just want to make sure, but that looks more like what I expected, because usually on Handmade Hero the font is much bigger than it would normally be, like than it would normally be if you were actually programming, because of the limitations of streaming, you know, and the motion compression and all of that. But that looks like the right size to me. So I'm going to say that that's about right, unless anyone has any objections. So let's see. Yeah. Okay, so let's recalibrate here. Also, I should restart the timer. There we go. What was today? 504? 505 maybe? Let's find out. Sorry for the delay. This always happens when your setup changes at all, because everything's so darn finicky. Let's take a look here. Yeah, 505, good. Yeah, let me see, 505. What does YouTube beta have for the last video that was updated? Yeah, 504. Okay, good. So everything's back to normal now, and let me just set this to start. What did we start at? 1:15, I think, is when we started the session. Oops. All right. 5:05. Everything's good. All right. So back to our program. What I was trying to say before was just that we want to kind of go in there and change some of that stuff up. So I'm just trying to get everything, just trying to, as we go through, and make sure that there's nothing particularly weird going on here. I'm going to change the contrast on this monitor a little bit too. There we go. All right. Looking good. So let's see. If we take a look inside the entity code, I was about to say why is it using 4096, sorry, sim region rather, because I don't really know why it was doing that. And you can see in here we kind of just have some constants for how many of each of these things we're going to have. I'm going to say that the entity hash here, just looking at how this was going, it looks like that. I don't know why we have this working this way. That was fine, actually, the way that that works. So this is actually what controls how many we have, and it gets pushed on dynamically. So we can actually change the number of these that we have at any given time pretty easily, right? And we don't really have to worry too much about that. But looking, we may want the hash tables to be a bit bigger so there's no hunting through them. That's the only reason I was saying, maybe this does make sense. Because you don't really want there to be a lot of collisions in the hash. You want there to be some empty space in it so that you're not all, everyone stepping on top of each other. But again, that's all stuff we can tune a little bit later. So I'm going to, again, focus on the camera today then, because I'd like to get that into a stable place where we don't really have to think about it much till maybe much further into the development process. And the other thing that we do have that we might want to create, and I could do one of those now, is when we interact with a character, like let's say here, if we end up interacting with one of these orphans or whatever, because we're going to go through and create some of that stuff, and we're going to do a bunch of gameplay-related stuff soon. And so we kind of have to start thinking about how all that stuff's going to play out. I want to be able to have it, too, so that if there's an interaction, maybe it zooms in on the interaction a little bit, too. And we added support for that. There's sort of this notion of camera, special camera regions involved. And you can see inside the entity struct, there's like different things here where you kind of get like the camera behaviors for entities are, there's sort of like this notion of special camera information that happens. And inside the entity code, inside the sim region code, where we do the update camera for entity movement, one of the things you can see here is when it goes through and looks at sort of what kind of stuff is being in, what kind of enclosures the user is on, right? What kind of enclosures the player is on. You can see here that there's a notion of a special camera in addition to an in-room. So you can kind of see that when we go through the entities and look at which ones we overlap with, you can see that there's room entities that we could overlap with, and those room entities are things that we will then use. But in addition to that, we also have this notion that different other kinds of entities that we might be interested in can also have camera behaviors associated with them. And those camera behaviors can be things that we maybe like let's say to zoom in or whatever. So we may want to, create one of those so we can test to make sure that that's working properly. And so we can see whether or not those sorts of things still work, because we would like those sorts of things to work. So I want to put in one of those, and if you look, you can see the special camera, there's like some stuff here where we say like, oh, there's an inspect and stuff like that, and possibly an offset. And so those can set these target Z's to different values than they would have been set to. You can see it normally sets one here, right? And we've got other things here that we're doing that set those up. One of the things you can see is the new target P gets set to the simulation center, and we do some things here to change that, right? You can see the camera arm and stuff. We want to make sure this code flows correctly. It probably doesn't flow correctly anymore. We want to make sure that's correct. So let's go ahead and just read through that and make sure that's going properly, and then we'll go create one of these entities and make sure that works too. That way we can sort of verify like all the camera code and kind of hammer on that a little bit more today and just make sure that's working right. So you can see in here, once we know which room we're in, we're going to say that there's a volume of that room, and here it is, right? The collision volume part of this. And we've got this notion of the simulation center, which is what we're going to simulate around. That just gets set to the center of the room, and that's fine, right? So then in here, we sort of set the new target P to the simulation center, but if you look at kind of what happens there, it's a little nonsensical, really, to be honest. So yeah, it's a little bit dumb, but it's fine. So if you see what's going on here, what we say is, look, let's default to setting it to the simulation center. And then later we'll do some stuff with the camera arm and stuff like that, right? I don't really think that's how we want to necessarily do this. I think what we want to do instead is say, look, the simulation center is always something that we're going to set. So you can see us doing this here, right? We're going to set the simulation center, and that's non-negotiable because the simulation center always takes place around the room. Rooms are sort of our fundamental semantic concept in Handmade Hero. And so we want the player to also be kind of under the expectation that the game generally is aware of what room you're in, and there's things that happen based on the room you're in, right? So, you know, if you're inside a cursed room and you can't use a certain magical power or something like that, the player understands that and the game understands that. And so we generally want the concept of the simulation to just be about the room. And that's just how, like, so this is all just, you know, a given. And it's not going to matter whether we're focusing on a particular part of a room or not. That part is sort of non-negotiable. So then we get to the part where we're like, okay, we've got, where do we want to actually look at with the camera? Because remember, we can simulate around the room, but maybe we're focusing on one part of the room. So those are not necessarily the same thing. So we start out by saying, well, let's pretend that we are going to focus on the center of the room, which is the simulation center. And let's pretend that we're going to focus on the target offset Z, and that's all going to be fine or whatever, right? And so that's what we're going to do here, right? And let's sort of feed forward from there. The other thing I want to do is take a look at how the special camera stuff is working here. When we look at the camera behavior, okay, so one of the things we also see here is that, you know, the special camera information. So special camera can be related to the room, or it can be related to an entity. So if you look at what happens here, room always gets set by whatever the room is that you're in. But the test entity may have camera behavior, and that camera behavior can get specified whether you're in the room or not. Now, this means that there's some stuff that we have to do here that we want to make sure we do correctly. And right now, we're not really doing it correctly. So what you can see is, you can see us setting the special camera. And we're setting the special camera based on whether or not we had a room with a special camera or any other entity with a special camera. That's not really what we want to do, because the room itself may overlap the entity, as well as a special part of the room may overlap the entity. So we don't want the room to override a special camera if there is one. We only want to use the special camera information from the room if there isn't another special camera information that we see elsewhere, right? So what we want to do here is almost like an else clause, right? I think so. We want to do some stuff here that we want to kind of move this stuff. We want to move how this logic's being done. And we want to make sure that the room won't override another special camera. So the easiest way to do this probably is to say, look, if there's test entity camera behavior on here, then when we go into this loop and we see, you know, we're going to do some stuff to see if this passes. If it does pass, we want to do a check in here to say, look, if this is a room, right? So if, you know, test entity equals in room. Or maybe a better way to say it would be if it doesn't equal in room, right? So this is some more specific region of the room we're specifying. If it's not equal to in room, then okay, we can apply this camera logic just fine, right? However, if it is the in room, then we only want to do it, we only want to override it if this thing doesn't have if there wasn't already a special camera. So if there wasn't a special camera, we'll take it. Otherwise, it had better not be the room. Now, we may want to make this even more specific than that. You could imagine circumstances where we actually had many different camera regions overlapping and we wanted to merge their behaviors together. I'd rather wait till we actually have that situation, because I don't have any way to test that right now. And so I don't really want to necessarily write code that tries to figure out what you mean if you have overlapping camera regions. You know, did you want to apply both of them or only one of them? You know, what were you trying to do? And so I'm not really going to get into that right now. But I would like to make it so that it works for the region inside room case regardless of which order the entities come in. So we're going to do that like this. All right. So once we get into the special camera information here, and you can see us specifying that stuff here, what I do want to do is then make sure that this works properly. So if you look here, we can update the target axes, which is something that we've already tested when the room itself is setting that value. But then we also have a thing when if there's an offset, you can see us saying here, like, okay, what are we going to do there? And what you can see is we're taking the XY and we're changing the camera offset using that XY. I don't like that. What I would rather do is I would rather have that offset for the camera actually be based more on the location of the entity itself, which right now it wouldn't be, right? So right now that camera offset XY would be relative, and I don't really want it to be relative, if that makes sense. So looking in here, and there's a couple other ways we can write that. We could write it as an offset relative to the player as well. So I don't know how we want to do that, but excuse me. There's a lot of ways we could do this. And I think the right way is to say, let's make it relative to the actual entity, the actual enclosure that you've specified for the camera behavior. So when you create the entity that's like got the bounds that says when you're inside these boundaries, use this special camera, let's make it relative to that. So in order to do that, we don't want to do simulation center here, right? What we want to do is take the test entity's actual location in XY, which it has, and then we want to add the camera offset XY. So in other words, you can still create an offset if you want, but we're going to start at least in the middle of that thing because that's probably where you wanted it, generally speaking. And if you want to move it one or the other, you can do that, but we'll, that's sort of an additional thing. So we want to cold set that and make that just work. And whether or not we want the Z to be based off of that, I couldn't really tell you. That's something we're going to have to think about a little bit more. But I suspect we want to not do that. It's pretty hard to say. I don't know. Yeah, I don't know. So the target offset Z should definitely be this Z because that's the one that says kind of how far you want the camera away. What I'm debating is saying, okay, the new target PZ, rather than being the simulation center, that might want to be this. So, I think maybe another way to write this, right, would be to say, let's maybe just say this. So, look, we're going to target whatever this test entity is. That's where the center is now. And then we're going to take the offset in XY, and we're just going to apply that onto the XY as a displacement if you wanted to shift it around. Most of the time, that'll be set to 0. And then we'll use that Z for the target offset, and that's just saying how far you want the camera to be pulled back. Then when we come through here, we've either set the new target P up to be focusing on that camera entity, or we've set it up to be focusing on the room center, one or the other. That's totally fine either way. And then what we'll do is we'll say, okay, now we've got, and remember, if this was the room, then it'll just do, it should in theory just do exactly the same thing, although maybe not. So no, but you wouldn't have this flag set for rooms either, so that's fine. So it's probably all good. So I think all that makes sense. I think all that would be fine. And then when we get down here, it'd still create the camera arm, which is off of whatever the angle the camera's being set at the time. So I think this all works correctly, and it should just flow through here and be done in line with everything else. So that means now we have to actually create one of these. Like we've got to put a thing into the world somewhere that we can use as a test, and we probably want to make some way of actually seeing it as well. So we might want to have some entity bounds in there or something, or like some way to visualize camera bounds. I don't know. We'll see. So we'll probably have to do something like that just to make sure we even have one, because we don't really know otherwise what those would be. So anyway, test entity is the wrong thing. It's special camera. I don't know why I said test entity. That's what I wanted. So I think that's all good, and now we just need to make one of them. So when we're inside the generation code, we need to put one of those entities in there so that we know like what that square actually means. And so how to do that is probably a little confusing. Just trying to think about how this would go exactly. So inside room gen, and we're gonna have to look inside world gen here. We have these notions of placement options, right? And an option is saying, look, here's a room that this thing can be placed in. You know what I mean? And so if you remember how this was going inside world gen, we did stuff like, oh, well, there's different rooms that different orphans can be in, or just orphans in general. And we have this add option call, right? So we said, like, look, here's where orphans can go and here's where cats can go. And we haven't really, looked at this in too much detail, but that's sort of what's going to go on here. And so when we've got this gen option orphan, when we're inside the room gen, or I guess I should say, when we're inside the place cat or place orphan thing, you can see us iterating over the options here, and then we say, like, oh, here's the room, and then you can see in here, we'll just say, like, oh, we're going to place one of these entities in this room, and that's really all that happens. The room gen code then just kind of has to stick one of these things in there, and you can see, where it actually does this. Where's the placement stuff? Here it is. So you can see here, it says, I want to create one of these entities that you told me to place here, and I'm going to tag it up and then move on to the next one. You can see in here that each one just takes up one of the spaces on which you can stand, right? So what we would need to do here is create, when we're placing down a footprint for one of these things, we kind of want to now say, look, we've got to be able to place things that have a footprint of like 2 things, right? Or, 3 things or whatever. And we're going to have to do a lot more, we're going to have to do like a lot more stuff to make sure that our random generation makes sense. For example, if you look inside the game here, we're going to have to do things like make sure exits aren't blocked and things like that, right? So when we look at what's actually going on in there, we have to have some way of making sure that we don't place things in ways that make rooms impossible to play or things like this. So we're going to need more of that later, but for now we can probably start by just doing a little bit of work to make something that allows us to do sort of quick and dirty placement of things in a way that makes a little bit more sense than what we have right now. So for example, what I could do here is say, well, when we're actually going in here and doing like the generate room call, for example, let's reintroduce a notion that we had before, which is that we could have a grid that we keep track of locally that lets us know where we've placed things and where we haven't placed things, so that we can get a quicker way of like looking up what we've done and how we might want things to happen, right? And so if we go ahead and do that, let's say I create a thing that's like a struct here, which is like a room grid, right? And inside the room grid, we know we're going to have like an X dimension and a Y dimension. So we're going to have like X count, Y count, and then we're going to have a like gen room, tile or something like that. And this will let us create little local grids of the area that we can look at and do things with. So we can say like, okay, let's create a local tile set for this thing. This will allow us to quickly do things like look where we want to place things and search in them, so that we don't have to keep doing what we're doing here. So you can see the way I wrote this code, because we just kind of hacked it in there because we wanted stuff to work and we weren't working on this code yet. We do things like basically saying, okay, loop over the grid once. So we are effectively looping over the grid, and just choose one thing to do for every spot on the grid. That avoids us ever having to store what we did, right? It doesn't make, any difference really. And so we it's one way to quickly write this routine, but now that we want to really generate things that are actually playable and more interesting, we'd much rather have a way of doing multiple passes on that, right? So we can place things, search, ask questions like, can I get from here to here? And if not, that's a problem, right? Things like that. We really want to be able to specify this more specifically. And so, maybe we just for now have a B32 that says, is this slot open, right? Like, can you place something on it, is it traversable, and like it can either be set to true or false if it is or isn't, right? And so that's more like what we want to do here, and then we can kind of get more into it a little bit later. This can become a very complicated struct that has tons of information in it about the tile as we sort of go further on and make a little bit more specificity about that. So in here, we're going to want a way to initialize these and then ask questions. So what I'm going to do is I'm going to fall back to Snuffleupagus-oriented programming because I think that'll work pretty well here, where we basically just say, look, let's pretend we already had a library or a system in place that does what we want it to do. Let's make calls as if it could just do those things. And then we'll go implement that library, basically, right? It's like, pretend you had the library you wanted, use it, and then go implement that library. That helps us understand what we actually want to create here. And so what I'm going to do first is I'm going to pull out this code, and we're not going to do it this way anymore. So before we were doing a bunch of ifs here, and then we were placing these entities, what I'm going to do is I'm going to make that happen in a separate pass, so that, like I said, we can look for areas where there's places next to each other that are accessible and so on, right? And so what I want to do is go ahead and have like a for loop here where we loop over all of the entities that are available. And so rather than setting this thing, because you can see here we've got this notion of a pending entity, when we come into this routine, we have already in the pipe, we say, here's this room, here's all the entities that the world generator said, this is what we want in this room. So what we're going to do is we're just going to look at that list. And here's that list, right? We have the room specification. Well, it's not the room specification. That's a different thing. We have the room's placement list. This is the first entity. Let's just go over all of those entities now and place each one of them according to the rules of placement for that entity, right? So that makes this a lot clearer too. Now we can stop doing these things as well. So these have more to do with finding particular cells in the grid that are useful for this value, right? Useful for this placement that we're trying to do. And that's really more what we're going for. So here we're going to place the entity into a location, and then we're going to apply the tags. That is exactly the same as it was going to be before. And so all we're going to do now is we're really just trying to look this up, right? We're trying to get where this pending entity should be placed on. Like which entity it's standing on, like the floor, right? Like that, right? And so what we want is we want a way to say, look, get us some information about what floor tile we're standing on so that we can work with that, right? Now, right off the bat, remember I said, the reason that we want to start looking at this in more detail is sometimes we want to place things that take up more than one tile. So I don't really want it to look like this, right? And this is the Snuffleupagus-oriented programming part. We're looking at the usage code first, which is a great place to start here because it'll help us understand what we actually need. If I typed this, right, which is what I might normally type, I send the room grid down and I say, hey, right, find a place to put this entity in the grid. Well, the problem with that is you can see right away I'm only going to get back one entity, but I just said I may want two entities. I may want to place two different things down into this area, and so that doesn't really help me, right? I needed more than that. I needed more. I needed to have something here that was going to tell me stuff like, how do I get an entity with another thing next to it, either vertically or laterally or something like this, right? So I think what I want to do here is have a way of saying what's going to come back is going to be more complicated than this, right? And so I don't actually know offhand exactly how I want to do this, but it's probably something like this, right? Give me back this thing where I say find place to put entity, and it's going to take the grid, and I'm going to say something like, I want a place to put an entity with a place underneath it that's like traversable or whatever, right? And so the query will come back with some information here, probably something like min-x. Well, you know what? I think we already have a concept of this. This gen volume is exactly what we want. So, you know, this would tell us the region in which that would go. And, you know, I don't know, but I maybe could just do this, right? It's hard to say. I'm going to leave it like this for now. And the reason I'm going to leave it like that is because I think we're going to probably want... excuse me. I think we're probably going to want other information about what happened. And you'll see that in a second. So let's suppose we had one of these queries. When we ask, I'm going to ask for different kinds of things, and maybe we get back something like this. So this way I can say, look, you know, find one of these, and if you didn't find one, I need to take evasive action or whatever, right? Something like that. So right now, I could do something like this, where I say assert that the thing that we got back worked, right? And maybe I could just use is valid here. There could be like a thing that says, does the actual volume exist? But again, I just think I might want more information to ride on this thing. Like, for example, maybe these things... you know, when I specify that region, I might want to say, and I'm going to place an entity in one of them, but not in the other, or things like that. And I would need to know which one I'm supposed to place it in. So, you know, I just think there's going to probably be more information coming back from that. So let's say I you know, issue this query, I get this thing back. And so then I may want to do placement that works across, you know, multiple things. So when I'm doing one of these pending entities here, what I want to do in the world gen is say, well, when I have one of those pending entities, and I think those are specified in here, aren't they? I'm not seeing it, though. Gen room. Gen entity. Okay, so I guess we put it in here. So yeah, you can actually see this working in here. So there's the gen entity next, and then there's just the creator, and here's the tags, right? So when replacing one of these entities, what I wanted to do there was say, well, we also want to have potentially a way of saying that this entity has other entities that need to be placed next to it, or things like that, right? Because when you place one of these, like let's say you're going to place one of these orphans, or maybe there's other things like you're going to place like a sign that the player can read. Well, when they hop next to the sign, there's like a square next to the sign that you actually hop on that is the thing that says you can read the sign from there. You know, there's stuff like that. And while there's other ways we could implement that, there's ways we could go, oh, we'll look to see if the player is standing next to a sign and implement that way. I don't know that I want it that way because, for example, I may want you to hop onto different squares to say things like yes or no, or pick this or that. And, it's more logical to make the squares themselves hold that information, I think. So it's a tricky situation, and I don't know which one we'll end up using in the actual game, but I want to support that because I want to try that. And if it turns out that we don't use it, we can always delete the code later. So again, I don't really know which one I want, and that's the point. I'm going to explore, and I will settle on one when I'm done, but I don't want to pick a priori because that's a sure way of creating something that, is maybe suboptimal. You haven't tried all the things, so you don't know that you've done the right one. So in here, what I want to say is we've got a creator for this entity here, and I want to daisy chain these together. So in addition to saying the next one, I want to say there's a child entity basically. So you're going to create this entity, but then we're also going to like daisy chain it to this other entity that's going to come back, right? And I, again, don't actually know exactly how I might want that to work. It may be that this creator function wants to do that in a different way. And these tags are really more that will get read out in a way that it's hard to say how we're going to do this, but we'll see. So if there's a child situation, then what we'll do is we'll assume for now that what we're going to do is place those two things next to each other, right? We're just going to assume that. And what I also want to do is inside the box math here, we've got these sort of directional pieces of directional information. So I also kind of want to say, well, okay, if you were going to place a child, right? So, you know, essentially like this, how is the child like related to you? So if I had to place you here, you know, where do I have to place the child? You know, going from where you are to like where they are or something. You know what I mean? And that way I could say like, okay, I want you to place the dude here. I want the child to go, you know, here or whatever. Furthermore, I can be even more squinky about that and actually say like that this is a mask, right? So, you know, you see how we do it here where we have these box masks here. We could say that there's, you know, placement rules that just say this is how you place the entity. You can, you know, the square could be to the left or it could be to the right or, you know, north, south, east, west, whatever. So we can have a flags32 here where we basically say, hey, this is a box surface mask that says the directions, like allowed child directions, something like that. Or maybe just child directions. So that's where this child could be placed relative to me. And we just assume that we chase that whole thing down when we do the creation, making sure that it's legal the whole way. Furthermore, while we're in here, we can also say whether or not this thing would take up a square. Meaning, when we actually place it down, does it actually need to stand on this thing or doesn't it, right? And so there's kind of another piece of information here, which is a gen entity flag, which can say something like, you know, gen entity occupier or something like this. And we can stack other flags in there, but basically what these are saying, oh, and we already have this, flags. Those are probably not the same flags, though, are they? I guess I got ahead of myself before. Gen entity. Just take a look at what we're setting those at. Flags equals. Okay. Well, you know what? I have no idea who's using this, so we're just going to do this and find out, because I don't know who's doing the flags. So literally no one is using those flags. Like, there is no one who's actually, like, doing anything with those flags as far as I can tell. Let me double check that. Yeah, no, so no one actually uses the flags at the moment, which means I must have just put them in there somewhat provisionally, I guess. So I'm going to add them now. Right? So these are the gen flags. These are the flags that are, because, you know, we could, there's entity flags as well. You know what I mean? And so, you know, maybe those get set some other time. But in here, we're talking about, does this thing go on an occupier? Like, does this thing actually occupy a spot? Or doesn't it? Right? And, you know, if it does occupy a spot, then we know that when it's placed down, no one can move through that square, which is going to be important for us when we're reasoning about where we can and can't place things. So things that occupy a square, they can't block doorways, they can't create like a solid bifurcation of the room such that no one could get from one side to the other. There's a lot of stuff like that where it's like, okay, you know, we need to know when we place something, what's it going to do? So when we have this gen flag in here that says whether it's going to be an occupier, then when we're actually generating the room, we can actually look here and see if we need to place it or not. So in other words, the traversable reference that the thing gets placed upon will not get set to anything if this thing is actually not going to occupy that square. It will simply get the position, like it will get a position that says this is where the thing goes in the world, but it won't actually get a standing reference because it doesn't actually sit on the square in that way, right? So for example, if there's just a invisible cage, like for the special camera, that would be sufficient, for example. So there's a couple other things we need to be able to do here, but that's thing one. So if the gen flags say that this thing is an occupier, then it's going to occupy it. I may switch the meaning of this since most things that place on squares will occupy them. I'm thinking that what we probably want to do is not occupier. So we probably want to do something more like this, where we just say, okay, does this thing occupy or not? And we could do it this way. Because that way people don't have to set that flag most of the time, and we'll just reverse the meaning of it when we pick it, right? And that's just an easy way to make clear to 0 work, which I like better. 0 should generally be the default, and the more unusual circumstance should be the one where you actually set something. So in the occupier case, we'll set this up. The p-value for this we need to get from somewhere. That may come out of the query itself as well. And so that might be another, there's another good reason why that should be happening there. So again, other important reasons why we want that to happen. And so I'm trying to think of other stuff that I need to do here where we have that grid query. Oops, room gen. That would have a, I guess it's just a P, like a literal, does it take a world position? I don't remember which one this actually takes. So inside entity gen, when you actually call one of the entity placements functions, search for cat here, look where we place the cat. There it is. So what do you actually expect this thing to be? Gen create entity, right? Like what is that actually? It takes a world position, right? So I guess it'd be that, right? I don't actually know why it takes a world position. That might be something we want to change, because when you look at how that where it has to happen here, and we call place entity, isn't this going to get circular? Yeah, I mean this just goes kind of all around through all kinds of gyrations. It doesn't really make any sense. This should probably just be a straightforward positional location. It would be simpler. And you can see here when I say this is just garbage, I'm not kidding. It really is just garbage, right? Because you can see here the entity P just doesn't subtract. So really, this place entity call doesn't need to do this, right? It could be just saying, hey, this is where this thing is supposed to go, right? It goes there. None of that has to happen. You know what I mean? And so normally when you're talking about a placement entity, I think that just works, and we don't need any of this other stuff. That entity P placement can just occur. So I think that's all we really want to do there, and I think I'm going to leave it at that. But going back here to the gen room talker, so this would just be a v3p that was coming in here. And when you call into this function, these don't normally use the world position if they got a standing on value there. So this world position will become a v3 instead, which is relative to whatever the room generation is going to be. And so when we call in here and we say, let's place this thing, that will be the query P, not a world position, but the actual v3 position of the entity, if that makes sense. I'm going to comment this out for a quick second. Oops. Don't know what happened there. Sorry about that. I accidentally re-indented everything. So what I want to do now is I want to go ahead and push forward through to figuring out how this code would actually work with something that has to place in multiple locations. Like I said, we can sort of make that notion work that says like the child has to go here or whatever. There are some sort of issues though that are a little bit more difficult to address that we sort of want to figure out how to do. When we place an entity and then we call the creation routine for that entity, one of the problems we're going to have is we find a volume and we kind of want to fill that volume. And it's going to want to use that volume to figure out how it's going to place its various things in it. So in a sense, too, I think looking at this, I think it may make more sense to say, actually, you know, as opposed to doing the standing on stuff here and so on, I wonder if when we place this thing, actually what we want to do is pass more like the room query itself. So like here's like where, you know, this is the placement query that that was done to figure out where you were supposed to go. And so that you can see the entire region. And furthermore, when you actually get called, you probably need your whole chain of what all these entities were that you were placing down. You know what I'm saying? So this part is a little bit more complicated and confusing to me. Because again, I'm not really sure exactly how this wants to go. And another way to look at it would be maybe the creator call, you know, it's possible that this part really doesn't specify an additional creator call, or maybe it does, I don't know. So we'll kind of have to see how we want to structure that code. It's tricky, right? But, you know, I'm just going to continue on from where we are here. So in terms of the traversable reference, you know, when we get that back, it's like, in this case, we may want to say, well, okay, the traversable reference is something that maybe is going to happen more inside that query as well, right? So this part here where we're saying, you know, we're on this floor ID and that sort of stuff, you know, this part may also be something that has to get handled in a more specific way. Again, not sure, just saying we're going to figure it out as we go. So when the query comes back, maybe it has all of this different stuff in it, so that when you get this placement query, you actually get all of this stuff here, and this is the standing on piece. And so when you're actually called to do that generation, then what we're going to do is inside the room gen call, right, we're going to actually pass you the query that we used to find out where you should go, and you're going to have to take it from there. You know what I mean? So that seems, you know, relatively reasonable to me. I think that all makes reasonable sense. And like looking at how these things are going to get tagged, it looks like this also is sort of a cascading process. So the main thing I'm not sure about is how this actually unwinds for people who get, you know, multiple parts of the query. So let's push a little bit further on this, because again, I want to make sure that this works relatively well, but I can see a lot of issues that are probably going to happen with it. Here's what I'm going to say. Let's suppose that what we do is we run through the sub-entities here. So we look at the root entities in series, right? And these are the things that are on the main chain. So each entity kind of goes through this process, right? For each root entity, we find a place to put it, probably like this, and then we assert that we can actually find it We maybe don't actually do this. We'll see what we do about that a little bit later. Then in here we go through a place entity or a source entity call, and that just starts at the root entity and goes through to each child. Something like that, because we're going to go to the child. But I guess we want to go, okay, so that's not quite right. We do the root entity, but then we do the children of the root entity as separate calls. So it's more like this. We start at the root entity, and we say that like the next entity I don't like the look of that loop either. So I would almost argue that it should look more like this. I would argue that we're really talking about two things. We're talking about groups of entities, and those go together like this. But they don't have tags because a group of entities can't really have tags, although you could make something that applies multiple tags to multiple entities. Then you have entities, and those have next pointers creators, and things like this, right? And in here we have first entity, right? This is actually what we're talking about here, if that makes sense. And this entity group, like I said, I'm not sure exactly how that wants to be specified in terms of the footprint that it actually needs. This may be a bad way to phrase it. So it may be that we want to do something else here, but we'll see. Again, we're just going to play around with it and see what happens. But this is really the structure we have. I didn't like the previous structure we had, so this makes a lot more sense. So in here, you're actually going to be saying, look, we're going to go through the groups of entities that have to be placed together because they sort of have, they sort of have to be placed in ways that they can cluster together, so they can't be placed free of each other. And so we go through those groups and we say, look, the room has a first entity group. And then we go through as many of those as the room has, right? And again, I'm trying to model the problem correctly. I don't really want to string it together in some other way. So then we say, okay, let's find a place to put this entity group. And here's the entity group. We assert at the moment that we found one. In the future, we may have to handle not being able to find one. And do some kind of fancier footwork there. But what we can then do is say, all right, now we loop through the entities of this group. So now we say, okay, we have like a pending entity, and that comes from the entity group's first entity. And then we just go through each of those in series, like so. And this is now much cleaner. So you can see that that now looks correct. So then we place the entity from the pending entity like we did before. This part will have to be worked out a little bit exactly how that's supposed to go. Because again, I'm not exactly sure. And so we'll figure that out in a second. But that's roughly what we need to do there. And then as we go through those entities, we can apply the tags to them as we were applying those tags before. And all of that should just work, totally fine. If that makes sense. So what I want to do now is just say, well, forget all the rest of the stuff. We just want to get this working in a basic, rudimentary fashion. So let's try to implement this just for the case we already had. And then we'll try to implement it for the more complicated case of having two things next to each other, right? So let's go ahead and switch back now to the room case. So in the room gen code, well, actually, I guess it's in the world gen code where we set things up originally. We have in here this notion of a gen entity. It's really going to be a gen entity group now, and we're going to have first entity group. So let's just deal with the code that had to group entities together first, and we'll fix that, and then we'll go from there, if that makes sense. We also want the room tile query stuff. I don't really know what we're going to be calling here. I think maybe what I'll do is I'll switch it back temporarily to what we were talking about before. Just to again get it working in a rudimentary fashion, and then we can kind of go from there. So this is a traversable reference. So we'll just get that working temporarily, and then we'll kind of push forward through the different ways in which that's going to go. We'll ping pong over to the other side of the implementation where we're actually creating an entity. We'll see what we want there, and then we can figure out how we want to wire them up together, because that's going to give us a very good idea of how those two pieces should look once we've seen both sides. So here's our first entity. Stuff that we're going to place an entity in a room. We got this sort of first entity, whatever nonsense, right? So if we're just placing an entity in a room by itself, so we essentially are saying we're just putting it in this room, that means it sort of needs to have a self-creating group, if that makes sense. So because we're just placing one. So that's totally fine. We just say, here's the group. This is like a single group, right? And so all we need to do is just say like add entity group to this room. This is the room in question. And then after we add that, then we we place the entity in a particular group, right? Place entity, and instead of a room, we just say like gen entity group. So it's saying put it into this group. And in order to do that, it just looks like this. It's the same exact code. It's just now it's on the group instead, right? Oops. So now we just are chaining them onto the end of this group instead. If you call place entity into a room, it will just add the group for you automatically, and we'll write this code. It's trivial code, right? All it does is allocate that structure and return. And so this then will just thunk through to place entity. Like so. All right. Place entity, in this case, just daisy chains on, so all of that stuff should be fine. When we place the entity group here, what that's going to do is just use the temporary memory that's set up in gen entity to make sure that it can access one of these or get temporary storage space for one of these. But that's about it. So all it's going to do is do a push struct, right? And it's going to do that on the gen temp memory, like so. It's just going to push on room for one of those. It's then going to set it up and link it in. I don't think there's any actual information in there. Oops. So there isn't, right? It's just a next pointer and a first entity. So right now we don't have any actual information there. In the future, we probably will put some information in there. We just don't know what it's going to be offhand. So anyway, its next pointer, it's basically this exact same code. So we just say, okay, the room's first entity group is us, and the room's first entity group then will point to us, right? So our next pointer just points to whatever was on the chain before. So again, it's just singly linked list, pushing it on there. So that's pretty trivial, right? Nothing fancy going on there. And in terms of this code now, we just need to actually implement something that finds an empty spot in this grid. And so now we get to the part we actually care about, which is the grid implementation. So let's start there. Again, this is going to be pretty straightforward. So when we come through here, we have the notion of temporary memory that we're using here, which, inside this temporary memory, it will all get unwound. So we can pretty trivially just take this, right, try to say this a little bit more cleanly. We have a giant set of scratch memory that we can just use while we're building the world. And this grid is a totally temporary structure. So we know that we can push this grid on trivially by just using the temporary memory that we have here. So all I'm going to do is just say, all right, we're going to create a room grid like so. So I'll push that struct on here where we say, all right, let's push the gen room grid on. We know how big the room is, right? Because we actually have this information. We have like min tile x, min tile y, and I guess technically we've got z as well, right? So we have the x count, the y count, and the z count. Those all exist. And since we have this this gen v3 thing where we've got the dim and everything, feels like we should probably use it as well. Maybe we can just do this. And so in here we can just say, look, the dimensions of the grid are exactly the dimensions that we had to begin with. And then the tiles is just going to be an array that can store all that, right? So we'll say, look, allocate in the temp memory something that actually just gives us this dimension all played out, right? So give us a solid volume filled with that much stuff and clear it so we can use it. And by the way, each one of them should be one of these. So this is how much room we want to store in there, right? So that would allocate the tiles for us. And then as we sort of march on through here, what we can do is say the tile that's in question here is just, you know, whatever tile comes from, you can see what's going on here. These are tiles in the real world, but we just want the tiles relative to the grid. So we're just going to say x index, y index, right? Our z index is always going to be 0 for now. I think we don't seem to set up a z index for whatever reason. I'm just trying to look here to see. It looks like we just don't use z at the moment. And so when we come through here to do our placement, it looks like we just use this floor tile z. So the floor tile z is just always the min z, which is always 0. So, you know, in a sense, it's that. Does this make sense? Or I should say, it's that, right? So really the tile in question is this tile, right? It's this. And another way I could do that is to say that the z index is 0. And that, again, is just the relative to the grid. So x, y, z. And that would return the tile to us. Okay? Now, we don't have to care how we index this thing. It's entirely at our discretion because we made the array and we can index it however we want. So all we really have to do is make sure that everything is in bounds, and assuming that everything is in bounds. And I don't know if we have... Do we have a in array bounds? No. So really all we need to do here is assert that all of these things are in bounds because we want to catch any errors that we may be making here that might otherwise be a little bit hard to catch. Don't ask me why that's greater than. I meant greater than equal to. So really we just want to make sure that all these things end up flowing properly. Okay? So in here we sort of have this notion, okay, there's a gen room grid. Here's the grid. The dimensions of the grid are specified by this dim parameter. So off we go. And maybe I'll just pull that out. So here's the dimension of the grid, which I pull out. Then I assert that, you know, the thing is within range. And then I just try to figure out, okay, well, if that's the tile that you wanted, then all I need to do is just take the tiles and offset them by, you know, these. So we have the z index, the y index, the x index. These will be multiplied by their respective values. So, you know, this is a standard dimensional striding that we always do. So, for example, the z index here, for every z index, it will go by the x and the y. And for every y index, it will go by the x, right? So x is primal, y is secondary, z is tertiary, right? Again, doesn't matter how you choose to index these at all. It may affect things like, you know, how fast the cache is or how well loops can be constructed or things like that. There are reasons to care about them in performance situations. We're not in one of those situations yet. So literally, as long as you map an x, y, and a z to your unique one of the tiles, you could have done this any way you wanted. You could have had x be tertiary and z be primal here. You could have done all sorts of things as long as you map them some way. I just chose to map them with x. Things that are neighboring in x go sequentially. Things that are neighboring in y go by x spans, and things that are neighboring in z go by xy plates, basically, right? And you can see that in the math here. So there's me getting a tile out of the room. So when I get one of these tiles, now I can fill it in with information as necessary. So now's the part we can start to fill out this struct with what we might actually store here. So it seems pretty clear what I would want to store here. At the moment, I add all this stuff in there, and really what I need to know is, okay, did I add a traversable, right? Did I put something in there? Can it be stepped on and all that sort of stuff, right? I need to know that information. So what I want to know when I go to place this entity, I want to know all that stuff. So for example, I want to know the structural entity, the floor, right? This thing. I want to know that. So the tile structural entity should be this entity. I probably also want to know if it's open or closed, right? And so the open or closed status of this thing is going to be related to this thing I said before. And again, this now, we can actually start to make this part of the routine a lot cleaner because as we're going to be able to use things on a grid, we don't need quite so many things happening all on top of each other. We can do things that maybe will operate in passes on the grid that will just clean up the code and make it easier for us to work with. It doesn't really change its correctness, but it will add power and ease of use to it for us, which is going to be important because this is going to be, these routines are going to be central to the game design process. And I'm not a game designer, so I don't want to speak to this aspect of it, but just what I can tell you from having observed and spoken with great game designers, I can tell you that having the code that's involved in design be flexible is critical. Like you really don't want pieces of the design-facing code to be brittle or confusing. That will limit the amount of iteration you can do, and it limits the amount of sort of experimentation that will go on just because the designer is being hamstrung and forced in directions they don't want to go by what is hard and what is easy in the code base. And so again, that'll be something we'll talk about more later as we go to start iterating on design things. You'll see me, I'll say that multiple times. I won't have a lot of advice for you on the design side of things, but I will mention things like that where I'm like, trust me on this one from having worked with great designers before, don't deliver them code that is hard to work with that they have to tweak, right? So that is just something that you'll hear me say multiple times as we go. So now you can see me filling out these tiles. At this point, that means that when we issue one of these queries, we can start to do stuff that will actually work here. If I wanted to re-enable this code here where we get one of these traversable references that then goes through here, what I can do is this on-floor entity now, I can look that up. I can look up into the grid who we actually found. So I can say here, and we could even put that back in the query to some extent, but I probably don't want to because you can get back a volume and you may want to look at all the tiles in the volume and do stuff with them. So when I get back a found here, what I want to do is for each of the entities in question, I would like to then go through and figure out which of these things we were doing, like who were we placing on, if that makes sense. And there's a lot of kind of subtlety here that I'll go into in a second. But basically what I want to do is say, well, look, let's see whether or not this thing's an occupier, and if it is, we'll pass down the reference. What I could say is since we don't need to do a standing on transaction, I don't know that we really need this. So the occupier flag is really going to be more for the query. I think we can always prepare this anyway. So we just need to say, look, whatever the structural entity is that you were standing on, that's the thing that it would be. And we don't really need to go into more detail than that. At the moment, anyway. So we'd really just be talking about, let's get one of those tiles. We know which tile we're going to get because we're going to essentially start right at a tile position. That tile position is the query that comes back is going to give us a P. That P is the tile position. Oh, sorry, that's not true. It's the gen volume min. So we know that that minimum value is where we would be starting placing things just for the moment. Again, that's why I say we kind of got to work this in phases because we got to figure out how that stuff's going to look a little bit later on. So we're going to sort of take that that volume min piece there and move that a little bit forwards. Then what we're going to say is this standing on thing doesn't actually need to happen. That can come out here. So here we create the reference. What we can do is say, look, the tile oops. The structural entity for that tile is what you're going to be standing on. We can make this predicated on whether there is anything to stand on there, which makes a little more sense. But normally there would be. Then it gets placed and added, and it's done, right? Now, this should work for single entity placement, but of course we want to get to multiple entity placement, so we'll do that in a minute here. But what we need to do here is like a to-do that's like update the tile P, because we need to kind of move through the volume. So we kind of need that to work a little bit better as we go forwards. All right, so let's take a look at where we're at. This needs to take the grid, which is good. We've got the grid, so that's fine. Pending entity here, that's not important anymore because that was just a check to see we were making sure we had an entity to place. We're placing the separate loop now, so that's not part of whether it's open. Open is now a separate thing. It's just saying, would we be able to place something on here if we had something to place? The check doesn't need to include whether there's something to place in the first place because that will only this loop will only iterate over things we do have to place. We haven't implemented this function yet, so we will implement that in a second. The get tile function here just needs to actually take the tile P in. And what I probably want to do here is actually have an ability to call this directly with a tile P that comes as a gen v3, because that's just going to be a little bit easier to work with. And so I probably want this to look something more like this most of the time. And so what I can do here is just say, let's thunk through. And this is just a literal thunk, right? It doesn't do anything else. That's it. All right, so that's that. We're down to just this, and this function actually is really easy for us to implement if we don't want to take into account, let me move over here so my head's not in the way. If we don't want to take into account the sort of harder next level stuff that we want to actually do with it, it's pretty trivial. Because what I can do here is just say, well, all right, if this is the gen room grid, here's that entity group that I want to place. If all I need to do is find a place, and I'm just going to say a priori that we're going to just find one empty square to place this thing on, again, not doing the stuff I actually need to do, what I can do is just set this stuff up here a little bit more straightforward. Just going to go through and set this stuff up, where we just set the min and the max equal to the same location. Which is the XYZ that we found that was open. So it's basically going to look like this. And once we find that it's open, we'll also set it to closed. So don't place anything else here, right? Now we may want to do this somewhere else. I don't know how exactly we want to do that. We'll probably play around with that a little bit later. But, we'll see. All right, so here's our found result where we're going to say that we found a location. The P location in this case, I think we want to do we want to probably assert here that there's a structural tile. Because if the thing is open, it means there's something to stand on. So we kind of need that to be structural at that point. And so then what I would do is I would say, like, get sim space traversable for this one. Let me just see how that's happening in entity gen. So that takes a traversable reference, actually, if that makes sense. I think that's what we want the P placement to be, is wherever that traversable is, I think. That's my story, and I'm sticking to it. And so, I think this is actually, we probably want to create this thing like this, probably. So we probably want to do something like that. So we create one of these first. We create the P from that. We set the location here. And so I think that's mostly all we really needed to do. So again, we're going to search in the worst way possible, and we'll work our way up from there. So we're literally just going to take an X, and these can actually be U32s because well, because they can be. Although I'll leave them as S32s for now. So if we just go through here, like so, I can search throughout all of these cells. And again, this will be slower, and we will probably have to think about how we might want to do this faster in the future. But it's, it's relatively tricky stuff to do good spatial placement queries. It gets a little complicated, so don't feel bad. All we really want to do here is say, all right, there's a tile. Let's get the tile. We could step the tile pointer more directly. I'm not going to do that right now because, again, that's an optimization. It's an optimization I don't really need to do right now, and I'm not going to. And we don't want to do that because it complicates matters and leads to potential bugs. And so until we actually look at how we want to optimize things, I don't want to do anything there that could be introducing erroneous or errors in the errors in how things are working, if that makes sense. So entity traversable point is actually probably not what I want. I want that, I assume. Yeah. And so now let's debug just this part of the code. And then, like I said, let's ping pong into making this do the more complicated thing. If that makes sense. What is our dimz here? Oh, that's a little bit of a failure to update there. I was going to say that doesn't seem right. All right, so let's take a look at what's going on now. There's us looking for the grid. We're getting back a statement that it wasn't actually found correctly. And so it's unable to place like one of its things in there. So that doesn't really make a lot of sense because we should always be able to place stuff because we're just looking for tiles that are marked as open. And then we should set the result to true. Oh, I also needed to do this. So I lied about that. That would actually have gone through and filled them all up. So things that had two entities in them wouldn't have worked. All right, so let's see if we placed our entities properly. It looks like we did, right? There they are. And so there are people getting placed now. And so now we can try to upgrade that to placing things more intelligently in there so that we get two things next to each other the way that we wanted. So the critical part here is you can see once I get into here and I would want to do a tile open, like I'd want to occupy this tile, right? What I need to be able to do now is search through the entities that are involved in this entity group and see whether or not they could be placed down in the location specified. So if there's only one entity, it would just work. If there's more than one entity, it would have to look to see whether the neighboring squares in the directions that are listed would actually be plausible or not in terms of being able to place entities there, right? So we'd have to see whether they were open nearby, if that makes sense. So yeah, in terms of doing that process, and also another thing I wanted to look at here, what are we doing for gentile P? So we get the query P and we send that down. So yeah, so looking at this, for example, when we're placing these entities, I'm just trying to think through how they would actually go in. We don't probably need that query P there, but because this would get that for us, so I kind of feel like that's just a known. Yeah, I'm not really sure how we want to do this, but I do think maybe that doesn't really happen. I think this is probably more where that should go, out here. So when we actually create this, we would make a v3, this sort of thing, you know what I'm saying? And that would get passed down, and I think that flows a little bit more correctly there. And we do have the problem of if we don't have a location for this thing. So, you know, it's probably more like this. And what we want to do here is initialize this value to something that would be sensible in the case where we have absolutely no idea what is actually going here. You know what I mean? And that's a little bit more tricky. So for now, I'm just going to clear, but I'm going to remind us here, right? You know what? I'm gonna do even one better than that. I'm just going to say, look, we didn't implement this yet. That way, in the case where we actually place something in a non-structural way, like this code will just fault and we'll come clean it up. Because this needs to get better. That's not going to be sufficient to actually get us through to a final piece of code. So we know we're going to be back there. All right, so what I want to do now is think about the dual entity placement case. And so I want to create this notion of a, you know, a text box or whatever, if you will, a place where we can put like bubble balloons or something. So, you know, if you're on this square, you can hop on the square and it will tell you like, you know, line of dialogue, that kind of thing. Like I want to talk to this player or something like that. I don't know if that makes sense. So what I want to do is I want to find some way of getting that worked in here. And like I said, we need some way now of placing two entities. This is a little harder than it seems. And the reason for that is because, as you'll see, when I go to place the camera entity, it's going to want to encompass both the the person you're talking to and the square you would stand on when you're talking to them, I think. Maybe it won't. But at the very least, it would need to, well, I don't know. Let's just do it and we'll see what happens. All right. So let's suppose we did the stupidest possible thing first. Here is a fine place to put entity group call. It loops over the X and Y of this thing, right? And what I want to do here is I want to do effectively a search to find what else is nearby to the various people here, right? So I want to do a thing that's like return to success or failure criteria. And I want to do like, or recursive open tile search. And what I'm going to do is I'm going to take the first entity of the tile group and I'm going to conduct the search from there. So I'm effectively going to say, okay, I know that the location I'm at is this gen v3 here. So in fact, I can actually just do this, right? Right. So I want to say, hey, if I pass a tile P down and I pass this grid down, so I say like, you know, recursive open tile search, do, you know, work your magic. And I want you to return me true if you can place this and false if you can't. Then what would happen here is we'd say, well, if, you know, recursive open tile search, and, you know, really, even this I could do even more succinctly probably this way, where we actually call into this thing first. Right? So if the thing works out, oh my, then, you know, we do this, otherwise we don't, etc., something like this. And so now, instead of just assuming that we can place on an open tile, we're actually going to call through to this function, and we're going to give it, in addition to the location to start at, I'm also going to give it the first entity. Okay? And so this will actually be the entity that we're trying to place, and we'll go from there. So here's that call will now get called off the tile P there, and this will happen however it happens. We'll see in a second. So let's suppose we were going to make the call structured like that. So the reason I want this to be recursive is because when we look back at how we've set up the entity groups, we have this notion that there's a next pointer, and the next pointer off of an entity group is going to have to say where the next person could have been placed, right? So here are the allowed directions for next. So what we want to do is say, if we were going to place an entity here on this tile, who do we have to place next? And when we go to place that next entity, where are the locations that we could place them? Okay? You can see why this is relatively complicated. But again, we're just going to brute force it for now. So what we're going to say is when we go to do this search, we're going to say, all right, if we found an open tile that we can place ourselves on, right? Then what we're going to do is say if our next entity, like whatever the next entity would have been, if the next entity could have been placed as well into the next tile P, then we're good, right? And we can break out of this and we can finish the placement. Otherwise, we can't. Make sense? And we also want to make sure we put on here, we need to put an additional thing on, probably that looks like this. And I'll talk a little about that in a second. So what I'm going to do is I'm calling this recursively. I'm going to pass the entity in question, right? We're going to look up where it was supposed to be placed, if it could have been placed there. Oh, and the other thing we want to do is to terminate this, we want to make sure that the entity actually can be placed at all. So something like this. We assume we can't place the entity. But, in here we actually would do this. And so what we're doing now is saying, look, assume you can't place the entity. Go in, find the tile. If it's open, we're asserting it's structural for now because we don't really know what we would do in the cases where it wasn't, but we'll probably eventually have to do something there once we know more about that. Now say, assume this tile was occupied. Keep trying to place future entities. If they all place successfully all the way down the recursive chain, when we get here, we'll say, okay, we succeeded, and we'll break out. Otherwise, we would end up here, and we'll set the tile that we marked as closed back to open, because we didn't actually use it, right? And we'll keep going. If there was no entity to place, that meant we hit the end of the entity placement chain, so therefore the result is true, because we know we've gotten all the way down to all the previous entities were placeable, and so now we're down to nothing, and we just say, okay, that means it worked, right? So the only other thing we have to do now is figure out how to update this next tile P, right? Because we're not doing that. So we need some way of saying what would the next tile P be, given that the first tile P that we started with was here, and that we have a flag that says which directions we can go here. Well, we know we have some number of directions we can go from a tile, right? And we just don't know which ones we can use. But we can pretty easily find out. All we have to do, and in fact, I guess I could even just do it this way. Right? So when we break out of the loop here, well, setting this back, I guess we can't, because the way that that breaks out of the loop makes it so we can't do it. We don't want this to happen in there. So the way that we'd want to do this, right, is we want to go through all of the box directions that we have, and for each box direction, we want to check to see whether it can go there or not, right? And so this is, something like this. So we would say, okay, dir index equals 0, dir index is less than count. For each direction index, we will say if, and remember we have sort of a useful routines here that help us with this. So we can sort of say, look, what's the mask for this? So we can just say, whatever this direction index is here, for whatever this one is, if we're allowed to go that direction. So effectively, we would say, look, if our child, what do we want to call this here? I can't remember what I called it. Allowed directions for next. So if the allowed directions that our next pointer, like when we move to the next one, if those allowed directions are valid, right? For this, if it would allow this direction to be one of the placed directions, then we will actually update it for that direction and try to continue placement. If it isn't, then we just don't, right? Because we can't even try, right? Because we're not allowed to look in that direction to see whether that's okay or not. And so then here, what we would want to do is say, okay, let me just look to see here if we've got one that gives us back the delta. It doesn't look like we do, actually, at least not in here. So we would want something in the gen. So in the gen math, which is this right here, we would want to be able to get a directional vector based on one of those. So we'd want to have a thing here that was like gen v3 get direction. And this would take a box surface index of direction. And I might do it like this. You can't iterate through enums for some stupid reason in C++, as is always the case in C++. So if I do that, right, that tells me that I can go that direction. And then what I would do is say, well, for the next tile P, what I want to do is excuse me, figure out what that direction actually is. So that's this. I would pass the dir index there, and it would just add to whatever my tile P was, right? And I don't know that we don't actually have an operator plus, so I would throw an operator plus in there as well. So I would need to do that, and in order to do that, you can see the way that we've got this set up here, where it's like set up in this sort of the axis index and then the positive or negative. So it's sort of like saying, here's which axis we're talking about, and here's whether or not that axis is positive or negative. So we don't really need to be so specific about what's going on. We can actually just say, give us the parameters for this surface index, which is that, right? That will tell us the axis index. So if we just initialize the result to 0, we can say, whichever one of these we're on, then if it's positive or negative is all we need to know. It's either going to be this or this, right? All on that axis, or I should say this or this, because it's scalar, right? So then I can just say, all right, if it's positive, it's 1. Otherwise, it's -1. And that's it. So that gives us the direction we would step to pretty easily. And what I need to do now in here is just say, well, all right, once I get a next tile P, I probably want to check to make sure it's in bounds to get that tile back. Now, what I think I want to do is maybe something, I don't know why there's not an internal on there. Oh God, the flash of death. What I probably want to do here when I call that get tile function is I want to have one that actually checks the bounds. And so if you look at what goes on here, maybe the better way to look at this, right, is that there's a test tile or like check tile. I'm not sure how to phrase it, but basically I want something that will return 0 when it's out of bounds. You know what I mean? So maybe, you know what, I could argue that that should just be always what happens. So, maybe this just looks like this. Because a lot of times you're going to do a fetch and you just want to say, is there a tile there? You know, I don't know, because I'm like procedurally doing some stuff. You know what I mean? And so you may actually want to do something more like this. You know what I mean? So there where we do a get tile, in here we would do an assertion because it has to always be true. But in other parts of the code, we would not do that. We would say, okay, it's not always going to be accurate. Or sorry, there's not always going to be a tile there. And that's actually fine. So when I do this call, again, working all the way through, now what I would do is I'd say, look, let's go ahead and get a genroom tile. There's the tile. I would use a get tile for next tile p. If the tile is valid, then we do this. Otherwise, we don't. And that handles the case where we were looking over the edge somewhere in sort of the placement scheme, and off we would go. Right? Okay. So the last thing we want to do here is we really don't want to do most of this stuff in the case where the entity actually doesn't exist. So if the child doesn't exist, we want to just consider it done. And so looking at this, it's not quite as nice as I would like it to be, if that makes sense. And so I probably need to do this a little bit more carefully that way. And so what I would do here is probably say something like, all right, let's suppose when you call into this with an entity, maybe what it does is it says when it gets down here, we will set the tile in question. This is actually the next tile, right? So maybe what we'll do here is say, oh, well, maybe we pass the tile in there. Hard to say. Or, well, you know what we could do too? We could actually also pass in the delta. Like this. That would probably work too. So what we would do there is we'd just say, okay, yeah, the tile comes by saying it's this plus dtile p. Dtile p comes from here, right? We don't ever do this. That doesn't happen. And we set the tile open or closed stuff a little bit more specifically. So we do this. Like so. And probably what we would do in here is say that we look, and if this never returns false, then we assume the result was true. Something like this. That's not quite, I don't love that either. We want to make this the simplest we can, so we're doing the least amount of work. It seems like maybe we need this to always pass an entity. So we want to do this check maybe inside. So we maybe want to do something like this. So we would say, yeah, in the case, to see if this flows a little better. So in here, we say, here's the tile P. I guess the D tile P could even be rolled into there. I suppose it's fine. We don't actually need to do that there. Right, that's fine. So we'd say, okay, look up that tile. If it's open, then we go ahead and close it. We then see if there's nothing else to place, we assume then we're good to go. Like, go ahead and exit out, like unwind the stack, and you're done. If we do have another entity to place, then let's step through each of these, and we won't assume the result's true. We'll assume we have to place it. So we'll test each one to see if we can. We will look for where it should have been placed, and then we'll actually, call the recursive function to keep that going. That seems good. So I think that's all fine. We can, if we want to, be a little prophylactic here and just say, look, if there's nothing to place, then we're just not going to return. We're going to return false because that's just a bad thing. So we'll just nullify that out, right? So that seems fine. I guess the other way we could do this is allow that. So maybe in here we could do something like, look, if the entity group's first entity doesn't exist, then just don't try to place it. We'll just assume that the answer is true, right? Right? That seems good enough to me. Although I can't imagine what you'd even be calling it for at that point, so that kind of seems busted. I'm just going to go ahead and say let's let that fault. Because why are you calling the function? What exactly do you think you're going to place at that point? So I think that's all we really need there, and I think that gives us what we want. When we actually go now to unwind this and we've found everything, we want to probably now set this allowed direction here to be the one we actually used. So we probably want to set the mask. So like we'd do this. So now we know that that's the direction it's actually going in. Maybe we don't quite want to do that. Maybe we want this. And then what we could do is say, well, you know, when we loop through these, we then want to know where did we actually place the thing. And so in here we could just say, well, here's the direction I actually used. Then we can finally answer this question down here, right? Where is it? When we actually need to go to update tile P, we can just do that because we can say, well, tile P equals tile P plus get direction, and it's whatever direction we actually used. So the placed entity direction used. Something like that. And so I think that's roughly what we would need. Let me just go through these one by one. That's actually that. That's all fine. What else we got? The plus we need to implement, and the plus we need to do that. So we knew that we had to do that, and so that's the only other thing we've got there. And so that's just the operator for these two. So that's basically just an operator plus between these two, which is pretty easy to implement, right? It's just this. Here's the result. So that just says, look, just add them the way you would, you know, normally. Next direction used is not a member of place entity. Is that really true? Next direction used. Oh, you're right. Sorry, I didn't mean place entity. I meant pending entity because we're actually talking about the placement instructions, not the result. So anyway, now we should be able to place double width things. And so, for example, in theory, if I wanted to place the cat so that it was below below the orphan, for example, I should theoretically be able to do that. We're pretty much out of time for this stream, so I don't want to go too long. We ended up doing a bunch of good generator work stuff that I wanted to do, so that was good. But we won't really have time to get to the camera part that I wanted to do, but we'll do that tomorrow. But I would like to just test to see if this is working, or so that we know whether we've got debugging to do or not, and so on. So in here, if I wanted to actually put a little bit more specificity in here, excuse me, When we do this place orphan call, what you can see here is it's placing, this add entity call, right? When I create one of those, I'm interested to potentially add it to the group that's getting constructed here. And so I could choose to place an orphan and a cat, right? And so I'm interested to see what would happen if I did that. So if I was to do, say, this, and I just said, all right, where we're going to do like the orphan placement thing here, I'm going to create also a cat. So there's going to be like a child entity here. You know what I'm saying? How would I do that? There's just going to be cats on cats on cats. You know what I'm saying? Just lots and lots and lots of cats. So if I wanted to create lots and lots of cats, how would I do that? Let's just take a look. If I want to string it onto this, I would basically say like, append or something. I guess actually it's here. Right? So I basically say add it to this one, maybe. I don't know if I love that syntax exactly. We may want to play with that a little bit. But it'd be something like this. And then I would have to give it some information about, in fact, I think I'd prefer it like this, which means I should probably flip the way it's doing here as well. Meaning I think room should probably come first. But anyway, in here I would need to give it that mask. So inside the mask stuff here, I would need to say like what directions it can be placed. And so maybe I say like, look, it's always got to be to the south. So if you place an orphan, you got to place a child to the south. Make sense? And so what I need is a call that will enforce that rule. And so that's pretty simple. All it's basically saying here is, look, I'm appending to this the group that this child's in. And so I should be able to just string it to the end of that with really, I don't think there's really much more to it than that. So here's the parent, here's the child, here's the mask. And so all we'd be saying here is, all right, the parent next equals the child. Child next equals the parent next, that sort of thing. So we just kind of like lump it on there. I'd have to assert that this doesn't already have a chain. So we may want to do this a little bit differently in the future. We'll see. But really, that's all we're talking about. And then we would need to set that allowed directions for next needs to be this direction mask. You know what I mean? But I think that's it. I don't think there's very much else to do there. It's not super complicated. So it should be pretty simple to build those chains. Now, whether or not they work, that's another question. Oops, that was supposed to be a not. Okay, so, yeah, so I was supposed to check to see whether that tile was valid, because again, remember, that's going to look off the grid potentially. So I said I needed to do that, and then I didn't do it. So unsurprisingly, it didn't work. So when we're searching here, this is actually supposed to be that. Meaning if there is a tile there and the tile is open, then we can proceed. And off we go. So it looks like it didn't find anything for a placement here, which means that since it should be able to find something, I think that means we screwed up, right? I'm not sure how we screwed up exactly, so we're going to kind of have to step through there and see. But I don't think there should have been any cases that it couldn't resolve, because all we're doing is placing like two entities into rooms with tons of empty tiles. So in theory, this should have worked just fine. And yeah, I don't know what would have been, what did I end up passing here? Box mask. So being able to place that to the south should have been fine. And so something in here is just not correct. This is wrong. So that could actually be part of the problem. So yeah, in fact, it's almost certainly the problem. So when we set open equal to false, we need to then check to see whether or not we've actually placed. So if we haven't placed the thing, then the tile open should set back to true, right? If we were not able to place it, if that makes sense. So I think that's probably fine. So let's see if we got what we wanted. It looks like we did. So you can see there's ghost cats, well, not ghost cats, but Hannah's being placed to the south of each one. Let's try briefly switching it to north just to make sure that that worked. And then I think we're done for the day. I'll take a brief Q&A. So here's north. And so this should have flipped. Yeah, and it did. So that's great. I think that's all I really wanted. And that's good. We can use that for lots of things. So I'm pretty happy with that. And so we will go from there. All right, let's go to a brief Q&A just to see if anyone has any questions about what we did there. Again, that was just, we ended up, oops, it's not what I wanted to type. I want to type it into here, Q-A. Oops, that's Q-S. That won't help. Come on. Q-A, return. So there we go. If anyone has any questions, I will be happy to answer them. And so again, the reason I wanted to get that done is because I'd like to put in squares you can hop on and that are related to the orphans, and then they can pop up some dialogue and stuff like that. And so I just wanted that to work. And the camera will just be a good way to test that out. And it will also let us make sure that our camera code is working properly, which I also want to do. So, any questions? Haven't done much on dump view lately as it's pending a rewrite in Odin. Okay. Seems like you had it all working. Why would you want to rewrite it in a different language? Could you make an elevator in the game? Sure. I don't think I will because I don't tend to like elevators much. So I don't know that we would have an elevator. We might have some things that move around like inside a room that are going around like this that you would jump on and they'd move, but I wrestled a beer. Hey Casey, off topic, is it beneficial performance-wise to use switch statements instead of if-else blocks? As far as I can understand from disassembly, using the switch statement allows it to compute where to jump to directly without invoking comp instruction for each case. Is that correct? The answer is it's actually kind of complicated. It depends very heavily on the optimizer. Technically speaking, there's really no reason that the optimizer can't just take a series of if-else blocks and turn them into a switch statement if they tend to test sequential values. The question is just whether it does or not. Furthermore, a lot of compilers actually don't optimize switch statements into jumps unless there's more than a certain number of switches. So I hate to sound like a broken record, but as I often say with performance things, unless you test it, you don't know. Every time. Like, pretty much every time you're gonna, if you care about that which one it does, you're just going to have to look and see. Because, you know, it will basically be entirely dependent on what the optimizer chooses to do. And you'll probably get different results between different compilers. So. Off topic, but I watched your 30 million lines of code and was wondering whether you think that Intel and other hardware manufacturers would be more likely to adopt an ISA as a response to consumer unfriendly policies from Microsoft if they're scared of the consumer PC market collapsing. I don't know, because the decision-making process inside companies like Intel or AMD is very opaque to me, and I don't really, you have to understand that large corporations like that it's not just like I'm sitting around and I say something and it happens, right? It's like there's a lot of meetings, there's shareholder meetings, there's boards of directors, there's all these sorts of things. And so large-scale strategic decisions aren't things that just happen because someone thinks it's a good idea. They have a lot of buy-in, and there's a lot of social and political implications of them inside the company. And so I have no idea, would be my answer. In terms of arguments I have made, it's definitely one I make often. I'm like, look, why do you want to rely on Microsoft to deliver you the platform you need to succeed? Why not just deliver that platform yourself, right? Why not just make an Intel chip that just runs? Windows does nothing. It's almost completely useless. Intel already ships things that have like Linux built into them, for example, like the Knights Landing, what do they call it? The Xeon Phi, right? Just, why don't you want to just ship a part that just works? Why? Who needs it? It's not good. Why not start shipping something that runs out of the box and see if people adopt it? Worst case is they don't. You have billions and billions and billions of dollars. It would be a small investment to make, and it seems like really good security, really good insurance. Why not? And again, it's just an argument. It's just an argument I'm making. But I don't know. I don't know what sorts of things resonate with them and what sorts don't. To be completely honest with you, I think in their mind we're the small part of the wheel of cheese, because their highest margin stuff is server stuff. That all runs Linux anyway. None of it's going to run Windows. And they know that going forwards, right? And the other part is they really want to be in like phones and stuff, right? They're trying to produce low power chips now, right? They're not thinking desktop. So while I think it is important to their business and they should care because there is money there and they're making that money right now and that money could go away and that should be scary, I think sometimes companies are more focused on their new markets and they forget to consolidate their gains sometimes and keep hold of them. I mean, it's how Microsoft lost a lot of its market, right? It's how a lot of the market for Windows went away, is they failed to see the threats to that market. And that's why there's huge segments of the market now that run on things like iPad, like iOS, or whatever. And Linux for servers. Are all the rooms going to be procedurally generated? Yes. Have you played any of the Souls games? What do you think of them? I don't know if I asked this question before. I have not played them, no. Is the game going to contain both 2D and 3D assets? Not really. There are 3D cubes, but no other shapes. Probably. Don't quote me on that. Maybe we'll add another shape someday. But we only allow structural cube tiles, basically, and then everything else is a spray. So it's 2D assets only, really, even though there is some 3D in it. Pithner, regarding Intel shipping their own platform that just runs, how would that look? Would there be a minimalistic OS boot once you power on the machine? Sorry if this is obvious, but I don't quite get it. Yeah, I mean, one way to look at it would be if you take a look at the actual hardware spec. So there's USB, there's NVMe, and there's the GPU that they're shipping. That together comprises basically a complete operating system API without actually having much else in there. There's a little bit you might want to do for task management, but you could also just leave that up to the people writing the software for it, right? Basically the hypervisor part. And so what I'm sort of suggesting is just write a 50,000 line program that is just a bare bones operating system that runs your chip, right? Publish the source code and let's go from there. You know, we can solve these problems, but there's such a huge buy-in cost when nobody will commit to an actual hardware interface that it's just never going to happen. I mean, you could even bake that stuff into the BIOS firmware, and that's not my favorite answer, but like suppose you did that, just even that. Then we would at least be back to the DOS days where you could write something that boots directly from startup and basically just uses BIOS calls, no OS, right? For the most part. So it's really just, I'm just saying, look, give us something, you know? Because I feel like we could have a good chance of making something reasonable if we just could take the ridiculously huge driver space we currently have to deal with and shrink it down to just a known set that people would agree to support going forwards. I think we could do some good work. That's all. So it doesn't even need to be settled. It just needs like work with us, right? Like work with people like us who want to do this low level stuff. Let's see if we can work something out, right? Is all I'm even saying. So we don't even need to agree on the specifics yet. Just let's get together. Let's have some streams where we talk about it. You know, let's just go take baby steps, right? Because I don't care exactly what form it takes. I have my opinions about what I'd like to see, but you know, I don't have to get my way. I just want to see something. I want to see something happen that gets us off of these big monolithic, unwieldy, problematic, unreliable, breaks all the time, spies on you, blah 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 blah, like listing all these things that happen, right? Favorite cheese? I can't pick. Sorry. There's a lot of really good cheeses out there. So that's basically it. Any more office moving drama and Sandy share has the reason for the move been talked about? Well, we just there was a better, cheaper opportunity, so we took it. There wasn't really any more drama though. It was just the movers were terrible. That was really it. All right, looks like we're out of time. I'm going to wrap it up. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along the series at home, you can always pre-order the game on handmadehero.org. It comes with the source code so you can play around with it and follow the series. It also comes with the source code for all the previous days. So if you want to look at a particular day, you can always jump back there and play around with something from a particular time period as well. That's about it for today. I will be back here tomorrow to then do the camera stuff because we decided we wanted to put in some Entity stuff today, so we did that. but I still want to do the camera code stuff that I talked about at the beginning of the stream. So we will give that a shot tomorrow, and we'll use the entity code we created to place some special camera markers that we can then test to make sure that the camera code actually respects them and does them properly. And then we'll sort of start tweaking the camera code a little bit more. I mentioned some things we want to do to it, so I'd like to do that and kind of get that to a point where I'm happy with the camera code. So hope to see you back here for that. Same time, same place, although we won't be delayed. We're delayed by an hour today. Hopefully tomorrow will be smooth because, hey, it looks like the stream's working good, so hopefully everything's fine. Hope to see you back here for that. Till then, have fun programming, everybody, and I'll see you on the internet. Take it easy.